Welcome back. In this lecture, we'll dive into the Polars write database function, which allows us to write data into multiple different databases. This is a task you'll be doing frequently as a data engineer. Thankfully, Polars makes this task both simple and fast. Let's explore the various options available when working with this feature in Polars. Before we go too far, there are a few additional packages you might need to install first. Those are SQL Alchemy and ConnectorX. You can install them using pip within the Jupyter code cell. I installed both of these packages prior to recording this lecture, so I won't be running these first two cells, but be sure that you do this before moving on. Once you have these packages installed, you should be ready to go. First, we'll start by importing our call center data from a CSV file using pl.readcsv. This file contains 200 records that we'll be transferring to our database. Let's take a quick look at our data to make sure it's loaded correctly. When we run the code, we have the first 5 rows of our data displayed. Now let's move on to writing this data into a database. To do this, we need to specify a Uniform Resource Identifier, or URI. In this case, we'll use a SQLite database called new database. As a note, this database does not currently exist, and we didn't include it in the course materials. We're going to create it here on the spot. Keep in mind that other database connections like SQL Server and MySQL will need to be created prior to making a connection. With that said, let's write our URI variable and specify that we want to connect to a SQLite database. After that, we just need to pass the path of the database, which we will call new database. Next, we'll create our first table by calling the write database function off of our data variable. Within the function, we'll pass the table name argument and call our new table call center. Finally, we'll connect to the database using the URI that we just defined. When we run this code, the data will be written into our specified database and table. We can verify that the new table is in the SQLite database by opening the database file. To do this, I'll be using a SQLite Viewer extension that enables me to view SQLite DB files within VS Code. Having this extension is not necessary for the course, but if you'd like to follow along, you can download a SQLite Viewer extension on your own computer through the Extensions Marketplace. Be sure that any extension you install comes from a verified developer with a certification icon next to it. To check our new database, I'll simply click on the DB file and open it. And our expected data is here in our SQLite database. Take note of how all 200 records from our call center data CSV file are now serialized into this table. So we've successfully created a new table. But what if you need to add data to this table or even replace it with new information? Polars provides us with this functionality as well. We can utilize the ifExists argument to specify what we'd like Polars to do if the table already exists in the database. There are 3 behaviors: append, replace, and fail. The default behavior is fail. If you tried running the code we just executed without specifying a different ifExists behavior, then you'll simply get an error. That said, let's demonstrate the other 2 behaviors now. First, we'll do a full replace of the table. We'll reuse most of the same code as before, but this time we'll add the ifExists argument and set it equal to replace. When we run the code, Polars will connect to the database, find the table, delete all previously committed rows, and replace them with the new data. In our case, the new data was exactly the same as the old. This means that we won't see any physical evidence that the database has been altered. Data engineers often use replace methods for tables where data is a current snapshot and doesn't require historic information. So now we know how to replace data in a table. Let's say you want to append or add data to an existing table in a database. We'll use the same code as before, but this time we'll set the ifExists argument equal to append. This will add our new data as new rows to the existing table, preserving the data already present. Let's take a look at our database again. Since the call center data is 200 rows long and we've committed it twice, we should expect to see 400 rows of data. And that's exactly what we have here. So now you've mastered the write database function. You have the ability to create new tables, replace existing ones, or append data as needed. Trust me when I say that this will be an extremely handy tool in your data engineering journey. Okay, that's all we have for this video. We'll catch up with you in the next one.